Anton Krieger here. This episode of All Things Green is brought to you by NextGen Clean Energy Solutions, your sustainability easy button from concept to completion. Welcome to All Things Green. I'm Anton, and today I'm joined by a very special guest. Jenny Amador is a systems engineer at the NASA Glenn Research Center working on electrified aircraft propulsion research. Jenny, how you doing today?
I'm so great. Thanks for having me.
Jenny, you have a really cool origin story about starting at NASA. Tell me a little bit about your fifth grade trip visiting the NASA Glenn Research Center.
Yeah, so I grew up in New Jersey.
It wasn't the NASA Glenn Research Center then.
It was not the NASA Glenn Research Center, but we went to a space simulation center, and I was nominated to be the class astronaut in fifth grade. And I thought it was the coolest thing ever. And I said, oh, when I grow up, I want to do that or something related to that. So knew I liked math and science and that I liked that experience. And then went to school for engineering at a college in upstate New York called Rensselaer Polytechnic Institute. And I was really fortunate to have breakfast with the then NASA administrator, Charlie Bolden, and the now commander for Artemis II, Reed Wiseman, who were both alum of my university. And they told me about this program called Pathways, which was an internship program. And I said, okay, well, if you guys are telling me this is what I should look for, I'm going to look for this. So I applied to every single Pathways internship that was remotely interesting to me. And I got one at the NASA Glenn Research Center here in Cleveland in the operational safety branch.
Yeah.
So that was my start.
So from classroom astronaut to intern.
Yes.
That's really interesting. Now, how does one get voted as classroom astronaut? I have to ask.
Oh, that's a good question. I don't remember in fifth grade.
That's okay. But tell me about some of the things that you worked on in your internship at NASA.
Yeah. So my very first internship was studying solar weather research, and we looked at coronal mass ejections, which are essentially giant balls of energy that come from the sun. And they're what causes the northern lights, and all of the solar activity that you see kind of in the news are caused by these solar events. I studied those and the atmosphere for a summer to see if you could predict when they would happen, and you couldn't, but it was still a really cool summer.
Yeah.
And then my next rotation was in safety, and I did a lot of like machine shop audits, and I got to see a lot of the center, and I met a ton of people through that. And then since my degrees are both in systems engineering, I said, how can I kind of get more into systems engineering and get slightly more technical? So a lot of networking and a lot of saying yes to different opportunities. And I was able to work on a fluid experiment that's now on the space station called the flow boiling and condensation experiment.
Wow. Okay.
I wrote a lot of the operating procedures and manuals for the astronauts to use, and I was able to set up kind of the build space efficiently for when they were actually building the hardware that's now in the space station. I did that for a summer, and then went back to school, finished school, came back, and then worked on a human health project for about 2 years. Still somewhat as an intern in the beginning, and then in the middle I transitioned to full-time employment. But I was working on like medical devices for long-duration spaceflight missions. So going to Mars, what kind of equipment do you need to bring to space? And is it better to have heavy-duty X-ray machines or Band-Aids and Advil per se?
Wow.
So I did that for a couple years, and then I've done a couple other projects since then. I was on a rotation with the center director's office for a year, and I worked high level at strategic planning and returning to on-site after COVID and how NASA Glenn kind of fit into the agency as a whole. And then I got into sustainable aviation. So
Wow.
long, windy road.
That's
Yeah.
very interesting. So it sounds to me like NASA took their best and their brightest and said, we need somebody who's really smart and somebody really organized that can be our systems engineer for sustainable aviation.
Yeah. Yeah. Thanks, Anton.
Jenny, tell me a little bit about what a systems engineer does.
Yeah, so there's a bunch of different kinds of engineers. And I really liked systems engineers because you have to know a little bit about everything. So I've always been a really big picture thinker, and a systems engineer is the person on the project that puts it all together. So I'm telling our experts who are really into mechanics and electrics and acoustics and all the different parts of an airplane. I'm the person that consults with them and goes, okay, how does this work? Are they doing things right? They bring it back to me, and I can put it all together into one.
Yeah, that's amazing. And green aviation, tell me what green aviation is. I mean, flight is only like what, 100, 110 years old, 120 years old or something.
Yeah, so there's a partnership that's developed called the Sustainable Flight National Partnership, and NASA is involved in this. Sorry.
That's okay.
I don't know what to call it. I guess it's a partnership. But NASA's involved in this partnership with the FAA, the Department of Energy, industry, and academia. And the goal is really to have net zero carbon emissions by 2050. So my project at NASA is hybrid aviation, and it's a part of this puzzle that goes together in this Sustainable Flight National Partnership work that's going on in the industry.
How did they come up with 2050? I'm just curious. I hear that one a lot. I hear that all the time.
Yeah, that's a good question.
Yeah.
I think it's far enough away that change can happen, but it's close enough away that like it's attainable and reachable and soon.
Yeah.
Because one of the exciting parts about my project specifically is that we're starting to do flight demos of our aircraft, and it's happening now in the next couple years. And so it's cool to be a part of a project in aviation that's now and happening in my lifetime. Whereas when I was working on space projects, they were so far in advance. Like going to Mars will be decades, but aviation is happening now.
Yeah. And speaking of the aviation that's going on right now, what is the commercial application for your projects? Will I, in my lifetime, fly in an airplane that has the parts that you worked on or the systems that you worked on?
Yeah, so I realized I didn't give you a good overview of my project yet. So my project is called the Electrified Powertrain Flight Demonstration Project. A lot of words for essentially saying that we're creating hybrid airplanes. We're working with two different industry partners, one called MagniX out in Everett, Washington, and the other GE Aerospace down in Cincinnati, Ohio. There's 4 NASA centers involved in this project across the country. So we're a cross-country effort to have 2 demonstration flights of hybrid electric airplanes. So we're taking lithium-ion batteries, which are just big batteries essentially, and putting them into these 2 different aircraft that these companies are working on independently to have hybrid flight. I got away from your question there.
No,
but
you're good. I'm curious, is it challenging to take all different kinds of partners, governmental, contractors, subcontractors? Is that tough to work with, to string something all together?
It's not. It's really fun. It's one of my favorite parts about my project specifically because we're working with industry, and industry is taking ownership of the projects and the flights and the aircraft. So it's really cool that they're so invested in greener aviation and more sustainability because we're able to partner with them really easily. And NASA's providing researchers and resources and some funding to go towards this effort as well. But it's really fun to work together with them.
Yeah, and how usually sustainability, we can measure things by reducing carbon emissions. Does your project have an amount of carbon emissions that is going to...
Yeah, we're reducing the fuel usage on our planes by 10%, which I know sounds like a small number, but 10% combined with all of these different other technologies and technology developments towards more sustainable aviation really adds up to being noticeable and changeable. There's one other flight demonstrator project at NASA, and they're changing the way the wings are created on the airplane and how they're shaped. So instead of being a traditional kind of flat squat wing, they're long and skinny. And so that changes the aerodynamics of how the plane flies. So that'll have impacts on the emissions. And so when you take all the different technologies that we're working on at NASA and put them together, that's when you really get the big impacts.
Yeah, so maybe it's 10% for your project, plus you add on another percent reduced of carbon emissions from somebody else's project.
Right.
Put it all together, and
Right.
by 2050,
Right.
hopefully we'll get down to zero carbon emissions, right?
Yes.
And how exactly does tech from your projects trickle out into the public domain?
Yeah, so our project will have flight demonstrations at the end of this decade, so we're kind of in the midst of starting. And then the technology is planned to be commercialized by 2030s, so in the next decade or so. And what that means is essentially we're taking the technology and putting it into aircraft. So since the technology is owned by our industry partners, they can distribute it to their industry partners and to their aircraft manufacturers to get this hybrid technology in the regional aircraft. So if you were going to fly from here to New Jersey or Chicago, the planes that are like 1 and 2 seats or 2 and 2 seats, the single aisle aircraft, those will be hybrid in the next decade or so.
Yeah, so if GE is partnering with Boeing, I think maybe you said off the
Yes.
air.
Yes.
Then if I'm taking a Boeing aircraft in 2035 or maybe even sooner, I will have been...
Yes.
I'll be flown by Jenny Amador herself, her own smarts.
Me flying the airplane. Yes.
And do these technologies, are these companies, I'm sure they're driven by the right morals and sustainability. What is the incentive for these technologies to be implemented by these flying companies?
Yeah, I think a lot of it goes into their investment in the Sustainable Flight National Partnership, since it is a government directive kind of that's flown down.
That was good. Oh, by the way, your earrings, I just noticed them. The airplane earrings.
Oh, yeah.
Pretty good.
Yes, thank you. Since it is a government initiative that kind of started the whole thing and it's a partnership, the airplane manufacturers and aircraft industry want to keep up and they want to do better with their sustainability.
Yeah.
So I think there's incentive for everybody.
That's awesome. And hopefully in the long term, if your project is able to cut back on maybe the usage of fuel or something like that, maybe it could even save the company in the long term for spending money on jet fuel or things of that nature. Is that true?
Yes. I think that this will have an economic impact on the companies because since we're using less fuel, that costs less for the aircraft manufacturers and airplane people to use. And it'll also hopefully get cheaper for us as passengers because if we're decreasing the cost of what they need to pay, we can reduce what we need to pay. But our passenger experience probably won't be any different on a hybrid plane than it is on a normal plane.
That's interesting because I know some people talk about the difference of like their electric cars or their hybrid cars, and maybe they feel different from like a gas guzzler. Yeah. But airplanes, you're saying it's going to feel the same.
I think it should feel exactly the same.
Yeah.
Yeah.
Well, that's reassuring because sometimes airplanes are a little bit scary for me. So if there's no extra turbulence, I think I'm on board.
I don't know if we can control the turbulence levels.
Well, that's good. See, I wasn't sure about that, but now that hearing it from a systems engineer, that's Okay. Well, what kind of new technologies can maybe the audience that are watching this, what are the kinds of things that we can be looking forward to, NASA's projects coming up?
Yeah, so one of NASA's really cool next projects is called the X-66A. And it's a sustainable flight demonstrator, and it's the first X-plane of its kind. So an X-plane is an experimental aircraft that's flying purely for science and research.
Okay.
And they've had 66 of them so far. But this is the first one that's focused on sustainability. So it's a really cool thing that's kind of in the works and happening now, mostly partnered with Boeing. And then I will be going to Oshkosh Air Show in Wisconsin, to the EAA AirVenture Air Show in Wisconsin, and we should have both of our aircraft unveiled at our at the air show this year in July.
That's exciting. And so your project, would you say now that those planes are being flown, your project is kind of winding down, it's wrapping up, or is this just the beginning of
No.
a new part on your project?
This is the beginning of a new part of the project. So we've been in kind of a pre-formulation, is what they call it at NASA. We're kind of getting everything aligned and ready to go. And we're still working with different industrial partners and with the FAA to get both of these flights approved for flight and ready to go. So we're just entering a different phase of our project once these aircraft get unveiled. Because we've already seen them, but for the public to unveil them.
Okay, well, tell me, as somebody of the public, tell me, like, it goes in the air, it stays up in the air. What else do you have to work on to make sure it's up to standard? You know what I mean?
Yeah, so good question. But the two aircraft that are being unveiled are smaller than what we're going for commercial use. So one of them is a Saab 340B, and I won't get technical with the aircraft, but that one has two different engines, and they're being hybrid, kind of similar to a hybrid vehicle, in that both the mechanism for both the gas and the battery are kind of powering the same turbine engine. And our other aircraft is the de Havilland Dash 7, and that has 4 motors, and 2 of those will be fully electric. So that's how that one is hybrid. But both of those are just kind of a test bed for the technology. So we're flying those, and then they say, okay, what worked, what didn't work, what can we make better? Let's keep flying these a bunch of times to see kind of how we can improve. And we'll do that for a really long time, for a couple years. And then the technology kind of gets the stamp of approval, and then it gets commercialized. So there's still a lot of iterations that happen between now and then.
Okay, great. So you're seeing some smaller planes with your technology flying this July, and then a few more iterations, and maybe we'll see these regional aircrafts that are taking off from New Jersey to Chicago. Does that summarize?
Yes, I think. So this July, our aircraft will be at the air show in Wisconsin. We'll have them there, and they will have flown. But we're doing different phases of testing, so it's not fully hybrid yet. We have phase cycles kind of with both of our industry partners, and that means different things for both of them with how they're testing and which parts they're testing when. So that's all happening kind of the end of this decade. And then we iterate and continue to do research, and then we'll have it probably by the end of next decade is the commercialization.
That's super. When we eventually get closer to 2050, will we see full electric airplanes, or do we always need a little bit of jet fuel and maybe offset carbon emissions some other way, planting a forest or? Yeah,
that's a good question. There already are some fully electric aircraft at a very small level. A lot of those are research-based, but it is kind of possible to have fully electric aviation. The thing that kind of is a big barrier is the technology for batteries and for alternative fuels. So I know that there's different types of sustainable aviation fuels that are kind of becoming much more prevalent in the industry, and there's different types of electric power that you can use and different gases and batteries and a lot of different types. So those are all kind of also being worked in concurrence with this hybrid approach that we're taking for EPFD.
Yeah. Aviation has been around for only a little over 100 years. The Wright brothers, born right here in Ohio. What does the license plate say in Ohio? It's like the birthplace of aviation, right? Yeah. Pretty cool. What is it like to be on the cutting edge in STEM, innovating something that's been so new? There's not like a playbook that's been around for hundreds of years.
It's so exciting. It really feels like there's a shift in the industry, and it's so exciting to be a part of as we're making these changes. Because I fly all the time, because like I said, my family's in New Jersey, so I see them frequently, and to know that I'm working on something that's going to make my life better by being better for the environment feels so good for my soul, and for just feels good to know that I'm making changes that are happening now and that have influence now. And it's really cool to see all of the public's interest and engagement behind what we're doing. So I've been going to Oshkosh for the last couple years, and the first time we were there talking about sustainable aviation, there were a lot of skeptics and a lot of people that, that's not going to happen, And now, last year, even when I went, there was so much more acceptance and, oh, that's really cool. Oh, I didn't know about this. And so it's cool to kind of see the shift happening both on the working side and on the public's side of how everything is being received.
That's beautiful. Well, Jenny, thank you so much for your good work. We are running thin on time, and so I just wanted to give you an opportunity to shout out anybody on the podcast.
I will shout out to my family. My parents have been so supportive of me, kind of from when I got into college to pursue engineering and through NASA. Like, my dad has a T-shirt of every single launch that has happened, and he will have one for our project too. But my parents have been so supportive, and my brother just has been supportive of my entire career as well. So shout out to the family.
That's beautiful. Well, we are going to wrap up here.
I do have something for you.
Do you?
I do.
A present?
A present. I brought you a sticker of our project. So we have the one plane, that's the Saab 340B that GE is working on.
Yeah.
And we have our Magnac stickers in the work, but I wanted to give that to you as a thank you.
Jenny, thank you so much. I have never been gifted anything on the podcast. So you're the first. Thank you. Play the applaud noises on the podcast. So this plane is taking off this July.
No,
in Oshkosh?
No. We'll have it in July I think we'll have it in July at the air show.
At the air show?
Yes.
But it's not taking off?
I don't think it will be.
Okay. Well, that's still cool that it'll be at Oshkosh, Wisconsin in July.
Yeah.
Okay. Well, Jenny, thank you so much for talking all things green with me. I'm going to let our viewers know how they can stay in touch with us. If you'd like to stay connected with the show, be sure to follow us on TikTok at ATG Show. And if you'd like to rewatch full episodes, check out our YouTube channel, All Things Green Show. You can find all of our sources from today's episode in our show notes. All Things Green will be back soon. Thank you so much for being a part of the global sustainability movement.